Hey everyone, today we are going to be doing applications of rational numbers notes, which is a nice way of saying word problems. But really what we're doing is we're showing you where you might use rational numbers in real life. So I can solve applications of real numbers, or I could have also said I can use rational numbers to solve real world problems. Either way, that's your learning target. And we will continue after I point out that I finally figured out that if I put the dogs on the deck and then come down here to my daughter's room, who is still as messy as the last time, and lock the basement door, I can maybe have some peace and quiet so I can make a good video for you. So I know many of you are in different organizations that have fundraisers. Band always has a fundraiser. Actually, Butler Middle School has fundraisers where you come around to us and you say, hey, would you like to buy something? And here's a plant type. Matter of fact, every year I buy from West Band for my plants. So please, because remember this is real life application, here's the fundraiser chart. And we're going to answer some questions, so we might have to refer to this awesome. So Tamara Jones, she brought tulips, 2 of them at $4.25. She didn't get a total, nor did she pay. So I want you just to pause and take a look at this and look at what each of the rows say. Okay, hopefully you did that. And I want you to notice that what it says is show your work. So we're going to be answering some questions, showing your work, representing it as a rational number. Now, rational, remember, just means that it can be put in A over B form. So it either could be a decimal, or it could be a fraction, or a whole number, or an integer. Any of those are rational numbers. What it can't be is an irrational. So, and then we have to explain. So this is where we get into that modeling and communicating mathematically. Okay, so what I did was while you were paused, I went in and wrote some information from the table. But I also found that my girls upstairs in the basement, I'm in the basement, so we can hear them walking. So I apologize for any bumping you will hear. All right, so first problem. If Tamara Jones writes a check to pay for the plants, what is the resulting change in her checking account balance? In other words, what this is asking is how much she owes. So this is just a simple multiplication problem. If she buys 2 plants for $4.25 each, and you should make sure that I have the correct numbers, I would just take my $4.25 and I would double it. So you could either multiply by 2, or you could add it, because remember, multiplication is just simple repeated addition. Either way, we come up with $8.50. So the numerical answer is $8.50. And my written explanation, the written explanation is what I've already said, is because she paid for it. And I'm not going to write it out, so you can pause and come back and listen. But because she pays for 2 plants at $4.25, the resulting change in her checking account balance, and this is what you're having to do for your project, is to subtract $4.25 twice, or twice $4.25, which comes up with $8.50. All right, next problem. Mr. Clark wants to pay for his order with a $20 bill. So you can see that I took this 20 and I just wrote it out here. The app that I'm using doesn't have a good highlighter, so I am just circling $20 bill. And he doesn't have change. So he tells Mr. Clark he will give him the change later. So the overall question is, how is this going to affect the total money he collects and explains? Well, and again, some of you get in the habit of just watching the video, not listening. So I hope you're listening and writing this down, because I am going to talk through the explanation, and hopefully you'll write something down similar, but not my word for word. So how is this going to affect the total amount? Well, think about it. If you were collecting money and you still have to give someone change, you'll collect all of the money, but then it is going to decrease that amount that you initially, it's going to decrease the amount that you initially collected. So it's going to decrease the amount by the amount he has to pay Mr. Clark back. So now we need to figure out how much change he is going to give him. So Mr. Clark bought, I hope I have this right, 5 plants at $2.25 each. So you could add $2.25 plus $2.25 plus $2.25, or you could just do that multiplication. 5 times 5 is 5. Carry the 2. 5 times 2 is 10 plus 2. 5 times 2 is 10 plus 1. So what Mr. Clark was supposed to pay is $11.25. However, the question again is now asking what rational number represents the change. Well, if Mr. Clark owes $11.25, we now have to take that away from $20. And since we have cents in here, I'm going to add my 2 zeros, and I have to start with the borrowing process way over here. And so I'm going to borrow 1 to make a 10, I'm going to borrow 1 to make a 9, I'm going to borrow 1 to make a 9, and I'm going to borrow another 1. So now I can do 10 minus 5 is 5, 9 minus 2 is 7. Here I'm going to bring down my decimal. 9 minus 1 is 8, and 1 minus 1 is nothing. So the change equals $8.75. Now remember, I just showed the arithmetic of it, but you still need to have, that is just such a weird E, you still need to have a written explanation to communicate. So use your words to communicate. All right. So Jeremy's sister Susie borrowed the money for their mom. Their mother has agreed, so she borrowed the money. Equal amounts is important. She agreed to deduct equal amounts from each week for the next 5 weeks. So what I looked at is how much Susie paid. So again, please check this on the chart to make sure I got that right. And this is going to be divided into 5 equal amounts. So we have to take the 5 and divide it, this is the division part, into $2.50. So 5 goes into 2 0 times. We bring up that decimal. 5 goes into 25 5 times. And we subtract. And then we bring down the 0 and it goes into 0 0 times. So the weekly charge in Susie's allowance is 50 cents. And last problem, Jeremy's grandpa wants to change their order. So originally they had 5 daisies for $15. So this is a $15, and again check my work on the table. So originally it was $15, but they wanted to take 1 daisy off and put 1 geranium on. So there are many ways you can do this problem. So first, though, we need to answer the question, how does this affect the amount of their order? So we have to look and answer in words, communicate. So communicate, and I'm hoping you are watching, listening, not just watching, because this is where I do the explanation. So how does this affect it? Well, if they were charged more first and the second thing they exchanged was less, it affects their overall amount by they are not going to be charged as much money. So, as I was saying, you could do this problem many different ways. You could take your three daisies times 375, and one geranium by 225. But mathematicians like to be efficient. So if we know that the overall effect is they're going to pay this amount less, so we can figure out, and I'll do this in red, they're paying $150 less than they were before, because originally the daisy was $375 and now they're only paying $225. So we can take our $15 and we are going to take away $150 from that. So now they are paying only $13.50, which is $1.50 less than they were originally. Okay, so those are the examples. I know application problems are sometimes tough. I always tell students to sit by me so that way you can ask questions, or I can ask you the right questions to walk you through the problem without telling you how to do it. So let me know if you need help. We out.